Welcome dear audience, students and scholars. Here I'm Dr. Amjad Ali. In this video we are going to discuss about dot plots. Dear scholars, one of the simplest method for graphing and understanding quantitative data is to create a dot plot. As we know that with the help of statistical software packages, we can make the graphical presentation of any type of data, as well as we can draw the dot plots for the large sample size or large population data. But here, for the understanding of the beginners, we are giving the demonstration that how to create a dot plot by hand. Dear scholars, the dot plots can help us deduct outlier, maybe the extreme value in a data set. Outliers are the values that are extremely large or extremely small with respect to the rest of the data values. So let's see the definition for the outliers are extreme values. Values that are very small or very large relative to the majority of the values in a data set are called outliers or extreme values. So these outliers actually create an issue for making any type of decision for the whole population, or based on some sample. So let's see the graphical presentation of the dot plots with the help of some empirical examples. So here we have the first example that lists the length of the longest field goal in yards made by all kickers in the American Football Conference, AFC, of the National Football League during the 2008 season. So let's create a dot plots and review that either our data has highest outliers or lowest outliers, or we have the average behavior or same average behavior of our data set. So first we have to understand that the minimum and maximum value of this data set. So here we have the highest value is 57, and we have the lowest value is 26 yards. So first we draw an horizontal line like that. We are drawing a line that is starting from 25. Either we have the lowest value is 26, but we are starting our horizontal line from 25, and we have the highest value is 57. So now we with the help of this raw data, we can put the dots of dot sign of each value. So place a dot of each value in front of each value. So for example, here we have the lowest value is 26. We put the dot here 26, and then we have dot in front of 43, and then we have 45. We have 45 two times, so that's why we put dot two times here. And then we have 53 four times, so we put dot in front of 53 four times. So likewise we put the dots in front of each value, and here we have the each value that represents the longest goal in measurement of yards. So we examine that the dots of this figure, we notice that there are two clusters of data. Approximately we have 70% of kickers made field goals from 50 to uh, 57 yards. All but one of the remaining kickers completed long field goals of 43 to 47 yards. In addition, one kicker uh, had a longest field goal of 26 yards. When this occurs, we expect that such a data value could be an outlier. Here we have 26 as an outlier. So dot plots are very useful for the comparison uh, in the data, within the data, and for the comparison of two data sets. To do so, we can create a dot plots for each data set with uh, numbers on the line for all data set on the same scale. We place these data sets on the top of each other, resulting in what are called the staked dot plots. So let's see another example, and then we make the comparison of the two data set. Here we have the data related to the distance of the longest completed field goal for the all kickers in the AFC and the information for the kickers in the National Football Conference of the NFL for the 2008 season. So here we have another information. So this is our raw data. We have discussed in our raw data discussion in an other video when we getting the information, and that is not arranged or not classified in any type of statistical methodology. That is our raw data. So from this raw data we can make the dot plots like that, and then we make the dot plots of our this data. So this is our previous slide dot plot, and this is our next this data data dot plots. So look at the stake plot. We see that the majority of the distance fall within a range of 7 yards to 57. So we have the highest 57 in both cases, and we have the shortest is 19 in both cases. So here 19 is the outlier, the lowest outlier in this graph, and here we have 26 as an outlier in this graph. So here you can see that we put the dots, as much dots as the information of that value is available as time in our raw data. So here we have 53 3 times, 51 3 times, so like that we have 53 4 times, 57 2 times, 26 1 time, and 19 1 time. So basically in our real world or in practice we have a huge data sets, and that huge data set cannot be handled manually. So that's why we use different statistical software for the construction of the dot plots, and that dot plots will enable us to see the highest outliers and lowest outliers, to see the average behavior of our data set. So this is all about the dot plots. So see you with another video. Ciao.